Hello students, today we are here with the second video on the chapter called Light Reflection and Diffraction, and we are going to start the proceedings of the video by the concept of the difference between real and virtual image. Real and virtual image. Children, a basic question is, what is the basic difference? It is an important question as far as your boards are concerned. What is the basic difference between the real image and the virtual image? Two differences I am telling you. Difference number one is the real image and virtual image. Children, the first difference is the real image is that image which can be taken on any screen. The screen means the screen could be your head, could be the wall, could be a canvas, but the real image can always be taken on one screen. The virtual image is that image which can never be taken on the screen. This is the difference number one. Always remember, the real image can be taken on the screen. The virtual image can never be taken on the screen. Difference number two. Children, the image which is real in physics is always inverted. What is the meaning of inverted? See, if it is object A and B, the image will become, it is A dash and B dash. You can see now, this will become this one and this will become this one. This is the meaning of inversion, inverted. So always remember the difference number two is, the real image is always inverted image, whereas the virtual image is always erect image. Alright? So these are the two basic differences. So this is an important question from the point of view of your board's examination. Alright? Now let us move further. Let us go ahead. What is the basic difference between the principal focus and focal length for both the mirrors? In the previous video, we have done some important definitions as far as the convex mirrors and convex mirrors they are concerned. Alright? Like for example, we have done center of curvature, pole, aperture, and so some other definitions also. Those definitions are common for both the mirrors, applicable in case of both the mirrors. But as far as the principal focus and focal length they are concerned, children, these two things are really different. Let us write principal focus and focal length. Focal length. Let us see it for concave mirrors first. For concave mirror, I make a concave mirror for you. Children, this is going to be the concave mirror. The pole, the center of curvature. Alright? Now, let us see. Children, if you take an incident ray, condition is the ray must be parallel to the principal axis. I take a ray, incident ray, coming parallel to the principal axis. Principal axis means this line. It will hit the mirror at this point and will be reflected in this manner, will pass through this point on principal, axis. You can take another parallel ray, I can take another parallel ray from here. The condition is the ray must be parallel to the principal axis. After hitting the mirror, it will be also passing through this point. Children, this point is basically defined as the principal focus for a concave mirror, and the distance PF is called the focal length. This separation PF, basically it is called focal length, represented by a small f, always a small f. So how can you define the principal focus? The basic definition, whatever you can see in the diagram, you can just convert it into words. Like for example, the principal focus for a concave mirror is the point on principal axis between C and P, through which all parallel incident rays parallel to the principal axis, they really pass after the reflection from the mirror. This is the basic definition of principal focus. Alright? The distance between pole and focus is called the focal length for the concave mirror. Let us now come to one more question. One question is coming to my mind before going ahead. Can you tell me, is it the case of real or virtual? Answer, yes, it is the case of real. Children, if one simple experiment, one simple activity I give you to perform, take a concave mirror in your hand and put a piece of paper at the principal focus. So you will see a lot of light will be focused at this point, and after some time the piece of paper will catch the fire. Alright, so remember, this is the case of real focus. Alright, let us now come to what is called convex mirror. See, it is supposed to be the convex mirror. Center is here, the pole is here. We are doing the definition of principal focus and focal length for the convex mirror. Children, take a parallel ray parallel to the principal axis. It will hit the mirror at this point, will go in this manner. If you see from here, it will appear as if it is coming from here at this point called F. Similarly, another option, you can take the ray parallel to the principal axis. From here, it will be reflected in this manner. If you look from here, it will appear as if the ray is coming from this point. Children, need not to tell you, this point is basically called the principal focus for a convex mirror. Question, is it real or virtual? Yes, as the diagram says, the answer is there, it is virtual. If you keep the piece of paper here, it will remain out to be here forever. It will not catch the fire because the things are not really happening. It just appears, right? They just appear. So this is the case of virtual focus. So children, once again, the distance between pole and focus, PF, is basically called the focal length of the mirror. Alright? So this is these diagrams are in front of you. They tell the entire story. What is the basic difference between the nature of principal focus for a concave mirror and the principal focus for a convex mirror? Alright, I hope this concept is very clear to you. Now, let us come to what is called the first formula of 10th standard of physics. What is the relationship between principal focus and radius of curvature, focal length and radius of curvature? Focal length is represented by small f, and radius of curvature is represented by capital R. Children, one important thing I wish to share with you in physics, you have done in 9th standard, we have used different types of symbols to represent different types of physical quantities. For example, acceleration was represented by F, A, the velocity, initial or final, they were represented by U and V, the force was represented by F, the mass of the body was represented by small m. Similarly, in 10th standard, in this chapter, we are going to use different types of symbols. For example, I told you short while before now, two symbols. Small f is the symbol for the focal length of the mirror, whether it is concave or convex. And R is the symbol for the radius of curvature in case of both the mirrors. So next thing I wish to discuss is, I wish to tell the relation between F and R. The relationship between focal length and radius of curvature. Children, for both the mirrors, F is always equal to R by 2. What is F? F means the focal length of the mirror is equal to radius of curvature divided by 2. This is an important formula, the first formula of physics of class 10th standard chapter is light, reflection and refraction. You can always expect numericals based upon this formula. If you know any one of them, if focal length is given to you, you can find out the radius of curvature. If R is given to you can find out the focal length and vice versa, right? So always remember, alright, this is. Another thing is, I told you I have already asked one question, simple question in video number 1. I once again wish to, asking the same question. What is the importance of mirrors in our life? The answer is, they are basically used for the formation of images in our life, whether it is a concave mirror or a convex mirror. So before going ahead, let us see the rules of formation of images by both the types of mirrors, right? So let us start what is called the basic rules, what are called the basic rules of formation of images by mirrors. Rules. I make two columns for you. Column number 1 is for concave mirror and column number 2 is for convex mirror. Children, I make simple diagrams. 3 times I am making concave mirror. This is another concave mirror. This is another concave mirror. And here I make convex mirrors. Number 2, number 3. This is the polish. I am doing polish. I am doing polish. Alright. Let us now see the basic rules of formation of images by concave mirrors first. Let us start. Point number 1. Children, this is supposed to be the pole, the center of curvature. Right in the middle, there is principal focus. So rule number 1 says, if you take a ray parallel to the principal axis, after the reflection, it will always pass through principal focus. Always remember, this is the basic or elementary rule of concave mirror. Alright. Now for this case, this is going to be the pole, the center of curvature. If you take any ray parallel to the principal axis, it will hit the mirror, will go in this manner, it will appear as if it is coming from this point called principal, focus. Alright, these are the 2 rules. Let us come to rule number 2 now. The rule number 2 is, this is the pole, center and focus. The rule number 2 is, if you take any ray through principal focus, it will become just parallel to the principal axis. What happens over there? Here, if you take, this is supposed to be the principal focus, this is the pole. If you take any ray, incident ray in the line of principal focus, it will be reflected and will become just parallel to the principal axis. Rule number 3, before winding up, rule number 3 is here. Rule number 3 means for concave mirror, this is the center of curvature. If you take the ray through center of curvature, it will be reflected back to the same path. And here it is supposed to be the center of curvature. If you take any ray in the line of center of curvature, it will be reflected back to the same path. Children, if you are able to remember these 3 basic rules, you are free to make any image formation by any mirror, whether it is concave or convex. In the next video, we shall be discussing how to make different types of images. Thank you so much. God bless you.